Hello. Want to talk water and watersheds, which is an area very close to my heart. Um, what I want to do with the lectures this week is go through really a lot of material. How do we understand water and watershed systems from the point of view of sustainability and resilience? And what does that have to do with what we, whether we're working with a community or with First Nation or in a provincial government process, perhaps, what can we do to move water and watershed systems towards sustainability and resilience? So my overall outline for the module is to start out with, I say ion implementation, but so what are the systems that are interacting with water and watersheds with an eye to where can we intervene in those systems? So if you think about what you read about types of systems, we have commons systems with water, we have different kinds of ownership systems with water and different kinds of regulatory systems with water, plus a natural system in which we both have impact and have ability to intervene in various ways. So that's what I mean with an eye on implementation. Like, here's the situation, what can we do in what context? And then what would work to improve sustainability and resilience? So that's really the first, this piece of the lecture. And then the next piece is, what are our sustainability and resilience challenges with water? How do we think about that in a watershed governance framework? And then I'll address as we go through, how is water governed in BC by all the different watershed governance actors, and in more detail, how do local communities, how do they govern water? What's their part? So I'm going to start out with the interaction of human and natural water systems, whose actions affect systems and whose actions can mitigate or control impacts or determine whose actions determine what those impacts are. So I want to start out with a picture of the natural water system, which I'm figuring that in some part of your science education or geography or at some point you've probably thought about the water system before. Excuse me, sneezing. We have evaporation from oceans and land up into the water in the air, in clouds, move with the climate, come down as precipitation on all those same surfaces. Some of it is evaporated again, some of it runs off on what we call surface waters, or some of it's on the surface, some of it seeps into groundwater, and many of our surface waters also have a groundwater component. Below most creeks, you often will see creeks in the mountain that are just rocks and later in summer, but often there's an underground flow that goes along with a creek. And then in that system, the various ecological units, the various ecological systems in the water cycle, in the natural system, handle water in various ways. And so, particularly with the water system, the wetlands unit is a very important part of a water system for cleaning water and holding water, and being a very important piece of ecological productivity in terms of sunlight, natural systems, wetlands, and some other parts of ecology in the ocean are where some of our fundamental ecological productivity comes from. So I'm going to use a simpler picture of that picture for the next little section. Here's a simplified picture of the natural system, okay? Same fundamental processes: collection, evaporation, condensation, precipitation, and surface and groundwater flow. And then, as we've been learning about, we have what I'd call an amplified water system. So climate change affects every part of the water system. So we have trouble figuring out whether this is now a natural system or a human system, because it's amplified in various ways. I say amplified, it's definitely changed, and there's more energy in the system, so there's more water moving around. Fundamentally is the change in the water cycle. And on this little simplified diagram, I tried to represent sometimes there's going to be more surface water flow and sometimes there's going to be less. That's in our mountain environment. We have other changes across the globe. And I haven't heard our scenarios yet, but I expect that water will be an issue in some of them. So what I call issue points. So to me, issue points are the places where we currently see a problem. So here I'm starting to think about social and regulatory and policy actions. We typically interact with a natural system where we see a problem. So if you look at, for example, even just who gets to use the water, our water licensing system in British Columbia, which changed recently in regulatory time, it was developed in a time when the original system was developed in a time when water was seen as relatively plentiful, but different users were licensed to make beneficial use of water, and beneficial use meant resource development and drinking water for communities. And what's interesting is we'll start to talk about the role of First Nations, is that First Nations often had their use of water was not recognized as original. So again, that's kind of a regulatory thing, but as we perhaps try to figure out a regulatory context that recognizes First Nations title, we're going to have to figure out how to recognize First Nations title to water and sort of order it in priority equivalently. And plus, we're going to have to figure out how First Nations land governance works into how we think about water. But so in terms of my issue points diagram, I'm really talking about where we've seen problems. So I want to, we talk about groundwater, that's kind of the licensing thing. Sorry, this is complicated. There was licensing to both surface and groundwater, but groundwater licensing until quite recently was done with very little information, and it was based mostly just on who wanted to make use of groundwater. And so where we start to see an issue point with groundwater is when we start to realize that we don't really have the information to know if that's too much or enough or not enough use of groundwater in a context, where we've started nationally and for decades to see issues with water quality is when we see an issue of people using the surface water systems as a way to discharge effluent. The dilution is the solution approach. So we have a whole regulatory context set up around how do we control pollution to water and where water is being used as waste disposal. We have an issue point that we're starting to see now with the effect of human use of the landscape changing hydrology. And when we change the soils or change the ecological communities, we change the hydrology of places. So that's an issue point. And then, of course, river management, which initially one of the issue points with river management was flooding. And then also we have river management for hydroelectric in British Columbia, huge basis for what's called the management of rivers. I'm using air quotes. But also internationally, we have river management as part of our international treaty agreements. So you can start to see that in terms of some of these issues, there's a lot of actors and a lot of layers of decision makers that are involved in what we are coming to see as issues. Water pollution, flooding, changes in soil and ecological dynamics, and supply and sustainability of groundwater. So those are our issues right now. And when we bring in climate change, we start to realize that we need to do a better job of monitoring flow and seasonal flow. Now, I've done a lot of work in watershed governance and nonprofits involvement, watershed stewardship groups. And one of the places that communities and one of the real points of action right now in water governance in the province is the push to get better information, which is important. You want to be basing your decisions on better information. So we're adding data, by which I mean adding data collection, adding data accessibility. So this is going on across the province in various watershed governance tables and roundtables, and we need to add more data on water quality. We need to basically do some basic water science. But then, to me, one of the linkages that's really important is then what do we do once we have that information? And how do we make sure that the science and the policies that we're advising fit with our current and future human systems? So it seems to me equally important to understanding the natural and the anthropogenic water system. You need to understand the decision system. So we worked on, we started out with systems theory. So let's think about who are the actors that are affecting the water system, water quality, water flow volumes, water usage, water, and the quality of our source water. Where are all the domains where people are having an impact on this system? So I've tried to sort of represent that sort of mapped on this water cycle system. So where should I start? I'll start with precipitation for this. So we have the entire domain of climate action. where we as individuals and corporations and governments make things worse or better in terms of how we do climate change policy. And so all of us are actors in that domain of the water system. So we can take actions that either affect or impact the water from a climate change point of view. We can make climate change worse or better. And then in terms of how do we adapt to those changes in the system, we can do that collectively as local communities, First Nations, certainly the Crown. I use Crown as because it's a shorter word than province. We can start to invest in some adaptations to this change system. So our last, climate change impacts, climate change adaptation, that's also in the water system. In terms of what's the quality of our source water, what's the quality of the water that we are able to access out of the ground or in the rivers or in the riverine flows, we can, the actors that affect or impact that, the way that our water comes to us are, people that impact soil quality, people that impact geological quality, people that make holes in the ground or spill oil into wells, or in an agricultural context, there's, that's often a concern, is where people's wells aren't properly capped. And land use. Land use here meaning, what are we doing? Forestry? Are we doing agriculture? Are we building? Are we building roads? So the you can think of all the actors, that is many natural resource activities, natural resource corporations, anyone that's working on provincial lands, First Nations, how much land use governance they have is going to depend on their governance agreements. And of course, local water users, many of which I've worked with. So local water users or anybody that lives on the surface of the land could have an impact, how you do your lawn, how you do your house, and cumulatively those things add up to the next piece is runoff water quality and quantity. So we're all, we all have an upstream water, and then our interaction with it can change it or not change it. So it goes to users further downstream, runoff becoming the water that the next people in the system have as source water. So clearly local land use decisions can impact water quality. We started to talk a little bit about that last class when we were talking about the flood zone in Prince George. If you had one of those 200-year floods, how would that affect water quality downstream and the ecological systems and food systems downstream? We can destroy or protect wetlands and affect other people's safety and our basic ecological productivity. We can have those effects. And certainly we know that we're affecting aquatic ecosystems with runoff. And just so at the point of river and ocean management, how do you see those same impacts coming there? You might see higher nutrient load from upstream land users. You might see higher waste load or hormone loads, where working in the Midwestern United States, the major problems with water quality are nutrient loading from basically using hog manure on crops. And so you get nitrates, phosphates, but you also have measurable quantities of pharmaceuticals in sort of larger river systems. So there's measurable quantities of things like Viagra and birth control pills and caffeine in many of the rivers in the US. And I believe in the more populated areas in Canada, this would also be the case. Remember, I'm talking about measurable levels. And of course, anyone that manages a municipality has this, most people have a sewer treatment plant, or you have septic systems in more or less good shape. So to what extent are those things effectively returning good water back to the water system? Those, in that sense, those users are affecting water quality. So you have the who can affect it, and then you have the policy system. So here you have some of the same actors setting the rules, setting the rule about, if you want to license water, do you have to make beneficial use? If you want to, you have to show that your use of that water is still leaving enough for healthy aquatic ecosystems. That's a relatively recent rule in British Columbia. So who can set the rules or change the system under which all those other actors act? And those things jurisdictionally depend on where the water is in the system. So that's one of the things that makes the system so complex. So in climate change, we have international treaties, we have federal government financial policy, tax policy, and any other actions they want to take. The provinces are very important in terms of how they set rules for actors in the water natural system in terms of climate. And First Nations insofar, typically adaptation at this point. But again, as the governance structure changes, First Nations may have more effective policy setting role. When I worked with the Tinaha, they have a water governance framework, and there's a issue between the province and First Nations, which I'm sure most of you know, about the status of First Nations' ability to govern their territories. How do they set policy for their territories? And so that varies very much between what the status is of governance or co-governance agreement. So for groundwater, we have the province setting groundwater licensing system rules, some of which they've recently changed. For water quality and quantity, you have a mix of actors. The federal government sets some of the rules in terms of, for certain waters, particularly coastal waters and fisheries. So they set some of the rules to what extent you're allowed to pollute in those waters. Provincial government sets other rules, and First Nations and local actions and funding, and how their tax policies are, and how their land use planning is, set some of the system rules up for water quality and quantity for other people. The river management will again be federal insofar as there's a fishery in the river, although they've really stepped back on the Department of Fisheries and Oceans has stepped back a great deal from fisheries regulation in the West. And so the provinces, particularly in British Columbia, the provinces action through its river management arms, like BC Hydro. I'm calling BC Hydro a river management arm. That's my perspective. So the province is very consequential. And I mentioned the treaty because, of course, I'm in the Columbia Basin in the Tanaha territory. So we're very influenced in British Columbia by our Columbia River Treaty. So, but overall, policy jurisdiction is the ability to set and enforce rules, water stewardship criteria, what you have to demonstrate, how much it costs to use water, all the things that could affect the decisions of those individual actors on the last slide. So once you get all these actors and all these jurisdictions in the natural system, which is itself changing, you can see there's a very complicated system or set of interacting systems that are in a thing as simple and as necessary as water. So is better information useful? Remember, we were keeping an eye on implementation. Better information, better science is useful from a systems perspective when it can affect a decision. So you have to have good information, so good scientific approaches to things like flow monitoring, water quality monitoring, effluent treatment and watering. But then it also must affect the decision. So for example, there's an effluent test that is used in places like pulp mills and other large industrial things, which is basically based on how toxic is it at its release point, how toxic is it to fish. So there's an actual test where you put the effluent in with a bunch of fish and see how many die in what amount of time. So there's a name for it that's not the fish kill test, but it's something 50, sorry. But it tells you when you need to intervene in your plant. So there's an effluent regulatory system. There's at what point do our natural resource activities have to think about land runoff? Well, there's a system in place where natural resource actors are responsible to the provincial government to show before they start that they're going to take care of their water runoff, or the measures that they're taking are not going to adversely affect streams, which is an interesting system for about the last 15 years or so. There's a thing called professional reliance in British Columbia where particularly, I know the system better in forestry, but it's the same across a number of natural resource activities. The company has to hire a professional, like a hydrologist, to basically certify their plan, whether it's setbacks from the stream or how they're crossing, how they're minimizing stream crossings with their roads. So they to certify that they won't have an excessive effect on downstream water quality. They don't have to, in many cases, they're not required to guarantee to downstream communities that their source waters won't be affected. And then the other big question, which there's many policy documents about, particularly one in the Forest Practices Board did one on the interaction between forestry and community water sources, small community water sources. What, and one of the big questions is what are the natural resource operators required to do if there's a failure? If, in fact, their activities destroy a community water system or otherwise impact the source water. So that gets us into a couple of other pieces of legislation, but the short answer is those companies aren't actually required to make up for those losses. So, and I decided not to put all of this in today's lecture because I could talk about water for hours, but large places in the scale of things, large places are like, for example, Vancouver owns its own source water watershed and protects it. Whereas places the size of, say, Revelstoke or Nelson have more influence over their source water watershed. But smaller rural communities typically don't have much ability to control what happens in their source water watersheds. And there are very few requirements from those upstream actors for seriously affecting either the quality or the functionality of those water systems for downstream users. So if you think about, okay, I don't want to talk too much about this, but if you think about the flooding that happened in Grand Forks, I think it's 2 years ago now. There's been a lot of forestry activities upstream in the Kettle River, and there's a sort of an ongoing dispute between people that use water for agriculture or drinking in downstream based on the upstream changes to hydrology that are forestry affected. But how much is forestry affecting it? How much is climate change? How can they be held responsible? Well, right now there's no system impact that says, hey, natural resource guys, if we can show that you have this impact, you have to pay. So we don't have that feedback loop in the water system right now. So that's that first part of the lecture, and I'll just stop that for now, and we'll come back to lecture 2.